Te- Tejasvi, I am audible to you now.
Yes, sir.
So, so this is the definition. What are elements? Elements is the basic unit of matter. We know that. Clear?
Yes, sir.
So we have to be classify the elements in such a way that the elements with similar properties are grouped together and different properties are put separated. So here early attempts are made by Dobinair. Dobinair made the triads. Dobinair made the triads.
Right.
Triads is of three elements. Either the atomic mass of all the three elements are nearly same, or the atomic mass of middle one element is the average of terminal two. Any problem, mera bacha?
No problem.
Newland gave the octave rule, according to which if we arrange the elements in increasing order of their atomic mass, the each eighth element show the similarity in properties with the first element. Any problem?
No, no, sir.
Mendeleev, it is the first systematic classification, and he said that the physical and chemical properties of elements are periodic function of their atomic masses. Means if we arrange the elements in increasing order of their atomic masses, the elements with similar properties are repeat after certain time interval. Did you got this?
Yes, sir.
Now today we are going to be start the modern periodic table, and modern periodic law is given by Moseley. Write down
Hmm.
this point. Modern periodic law is given by Moseley, and elements are arranged in modern periodic table by Bohr.
Um, um,
Modern periodic law is given by Moseley, and elements are arranged in modern periodic table by Bohr. Clear, मेरा बच्चा?
yes, sir.
So, what is modern periodic law? Write down this. The physical and chemical properties of elements are periodic function of their
Physical and
atomic
chemical.
properties of elements are periodic function of their atomic numbers. So, are you able to be tell me what is the difference between Mendeleev periodic law and modern periodic law?
Wait. Physical and chemical properties property functions of their elements are based on atomic numbers.
Yeah, physical and chemical properties of elements are periodic function of their atomic numbers.
Ah, okay.
So, what is the difference between modern periodic law and Mendeleev periodic law?
Mendeleev's periodic law used atomic weights, while Moseley's used numbers.
Yeah. So Moseley do some experiments and he find that atomic number is more basic property as compared to atomic mass. So
Hmm.
he take reference of atomic number. Okay. Means if we arrange the elements in increasing order of their atomic numbers, the elements with similar property repeat after certain time interval. Are you comfortable on the page number first, that
Yes.
is 79?
Yes, sir.
So Dobina tried any problem? This we
No,
have
sir.
discussed. Comfortable na? Newland octave rule, any problem?
No, sir.
So first two pages are comfortable, mera beta.
Yes, sir.
Then Mendeleev's periodic table.
No, sir.
Have you read up? So what is the limitation of Mendeleev periodic table? At certain point, he put up the heavier atom before the lighter element. Like he put cobalt before nickel, even though atomic mass of cobalt is 58.9 and of nickel is 58.6. Vivan, तेरे कोई काम का था?
Ah.
So it's a limitation, na? Even though cobalt have higher atomic mass, but he put it before the nickel. when we ask that its properties matches with this one. Clear?
Yes, sir.
He put lanthanoids and actinoids not in the main periodic table. He put them below the periodic table in two separate groups, that is lanthanoids and actinoids. Clear?
Yes, sir.
Now, isotopes have different atomic masses. Isotopes have different atomic masses. So basically, if you are classifying the elements on the basis of atomic mass, then why you cannot give the position to the isotopes in the periodic table? Clear?
Yes, sir.
So to overcome this limitation, the modern periodic table comes in a picture. And modern periodic table is also known as Moseley's classification. He classify the elements and he say that atomic mass is not a basic property. The more basic property is atomic number. Clear?
Yes, sir.
Clear? So
Yes.
modern periodic law we discussed.
Hmm.
So what is the difference in Mendeleev and modern periodic table? See, in Mendeleev, he can give 1 to 7 group with A and B subgroup. In 8th group, Mendeleev put up three elements together and a
Hmm.
zero group for inert gases. Clear?
Yes, sir.
So, what the modern periodic table or Moseley done, Moseley separate them all, means 7 into 2, the 14 groups become this one, 3 become this one, and 1 becomes this one. So in modern periodic table, there are total 18 groups. Clear?
Clear.
And periods are same, that is 7.
Hmm.
Understand मेरा बच्चा?
Yes, sir.
रुक जा क्या 10 बजे तक चलो एक मिनट. Now, what are the periodic properties? So in periodic table, there are certain properties, okay, which can show a regular gradient as we move from top to bottom in a group.
Hmm.
Or left to right in a period. Understand मेरा बच्चा?
Hmm.
The properties which show regular gradation. Gradation means either increase or decrease as we move from top to bottom in a group or left to right in a period. Clear?
Hmm.
Have you written this line? Periodic properties are the properties which show a regular gradation, in bracket increase or decrease, when we move from top to bottom in a group or
Please
left
go
to right.
slow.
Sorry.
Please go slow. Too
Okay,
fast.
okay. So just again, periodic properties are the properties
Okay. And
which show
with
show
uh,
regular gradation,
hmm.
in bracket either increase or decrease, bracket close, when we move from top to bottom in a group or left to right?
Left to right.
In a period. Understand, मेरा बच्चा?
Yes, sir.
So now we can first, the first periodic property is, you have three properties now. I can explain you these properties.
Hmm.
First is atomic size. First is atomic size. What is atomic size? Size
Size
or
of an atom.
radii. Atomic radii is a distance from center of atom to the outermost electron density. Let this is a nucleus, this is outer electron density. So from here it is known as term. Anything problem, मेरा बच्चा?
No, sir.
Can I move ahead, beta?
Yes, sir. Done.
As we move
Hmm.
from top to bottom in a group, atomic size or radii increases due to addition of a new shell. Due to addition of a new shell.
Great.
See, this is first period, second, third, and fourth. In first period, atom has only one shell. In second period, it can have a two shell. In third period, it can have three shells. So tell me, size or radii is increasing or not?
Of course, yes.
Note down this one.
Hmm.
मम्मी कहाँ गई?
Hmm.
तो पानी की बोतल लिया ले आए हाँ Can I move ahead, beta?
One moment.
Okay, okay. Tell me, okay? I'm waiting for you.
Okay, done.
Okay, atomic radii decreases as we move from left to right in a period. Clear?
Clear.
Due to increase in effective nuclear charge. I can explain you how. Tejaswini, we
Mm-hmm.
can move from boron to carbon. Okay.
Okay.
In boron, how many protons in the nucleus? Five.
What?
And
5.
in carbon, it is six proton. Okay.
Hmm.
In the first shell, there will be two electrons. Always
Yes.
be. And in case of boron, there are three electrons in outer shell.
Hmm.
Whereas in carbon, there are four electrons. So what you see that in the case of boron, five protons are attracting these electrons, and in carbon, six protons are attracting these electrons. Clear?
Yes, sir.
So as we move from left to right, the attraction of nucleus increases on outermost electron.
Hmm.
Why? Because number of protons are increasing in the nucleus.
Yes, sir.
Because the repulsion of inner electron is same.
Hmm.
Repulsion of inner electron is same.
Right.
Clear?
Hmm.
So when the repulsion is same, we can say that the effective nuclear attraction
Hmm.
increasing. As a result, size or radii decreases left to right in a period. Understand, mera bacha?
Hmm.
So, what the conclusion you can made from top to bottom? Size or radii increases, and left to right, size or radii decreases. Any problem, mera bacha?
Yes, sir.
Note down this all.
Done.
Okay. Now we are moving on a second point. Ionization energy.
Potential.
Sorry.
Ionization potential.
Or ionization potential. First, we can discuss energy, then we can move to the potential. What is the meaning of ionization energy?
So the affinity to form ions or the reactivity of an
Yeah.
atom to form ions.
The conversion of atom into ion by removal of electron. So the energy required for this process is known as ionization. So what is the definition? Ionization energy is the energy required to remove ionization energy, the energy required to remove outermost valence shell electron, that is loosely bounded electron, from an atom from its in its isolated gaseous state. Note down this. Can you explain why we have taken isolated gaseous state?
Gaseous state, because gas is most likely to react because the particles are in random motion.
No, no, no. Just tell me, Tejasvi, you have your younger brother or sister?
Elder brother.
Elder. Let elder brother wants to be just want to be take a revenge from you. He wants to be beat you. So when he prefer a time in front of your parents or in absence of your parents?
To be honest, I don't know because he never hit me in my lifetime, surprisingly.
Okay. No, just in simple, you can ignore that all. If you want to be hit any person, you hit that person when he or she is isolated or when he or she is present in a group.
That is
That is isolated. See, I can explain you.
uh, okay. Interesting
Because
scenario.
because if there are four persons are coming in a group and you want to be hit one person, these three persons help him and you required more energy to hit that person. Okay, but if only a single person is coming and they just only want to hit it, so the whole energy
Hmm.
is used for that person. Okay,
Hmm.
similarly, if you can take the atom in solid or liquid state, so many atoms are present close to each other. Okay,
Hmm.
in that case, some energy is consumed to separate the atoms. Okay, so no, there is not a whole energy used to remove the electron of one atom. But if we can take isolated gaseous atom, so this is a single atom now. So the whole energy here is consumed to remove the electron of this atom. The energy cannot be spent anywhere more, anywhere else. Clear?
Hmm.
So why we can take atom in isolated gaseous state, because we want to be find only that energy which is required to remove the electron only.
Hmm. Okay.
Write down that definition.
Which one? The one in blue.
Blue one. Yeah.
Done.
Done. Okay.
Hmm.
So if I ask you, as we move from top to bottom in a group,
Hmm.
according to you, the removal of outermost electron becomes easier or difficult?
Easier removal.
Why?
Wait, which one? In what case exactly? When
When we move from top to bottom in a group. You are correct, beta, but why?
because there is because losing a less number of electrons is easier than
No.
gaining a lot of
See,
electrons.
beta, as we move from top to bottom, the size is increasing now.
Yes, sir.
So the outermost electron go far away from the nucleus,
Huh.
and the attraction of nucleus on that electron becomes decreases,
Yes, sir.
and we required more lesser energy to remove that electron now, because this electron is more easy to be pull out. So
Yes,
we
sir.
can say top to bottom, due to increase in size and decrease in attraction of nucleus on electron, it is easy to remove that electron. Hence, ionization enthalpy decreases. Clear?
Hmm.
Let, for example, you like a chocolates very much, and your parents stop you to take the excess of the chocolate. So, let Tejasvi want to eat the chocolate. The one chocolate is present near your mama, and one is in the second room. So, which chocolate is easy to be taken by you?
Second room.
Yeah, the same thing is here. As the electron become far from the nucleus, it is easy to be removed. So from top to bottom, ionization energy decreases. Any problem, mera bacha?
Hmm. No problem.
And from left to right in a period?
And left to right in a period.
Yeah.
In of electrons.
See, from left to right in a period, size decreases, attraction of nucleus on
Hmm.
electron increases, hence ionization energy increases. Clear? Clear?
Hmm.
Understand, mera bacha?
Hmm.
Can we move to the next point?
Yes, sir.
So, ionization potential is the potential required to remove an electron. Okay. So,
Hmm.
higher is the ionization energy, higher will be ionization. Any problem, mera bacha?
Hmm. No, sir.
Completed, beta?
Wait.
चीज़ां मेरियां भी ते हमारे कोटियां खेड़नियां पईयां बहुत ज्यादा कर दिया कर पुत्त पापा दी निकता है आज ना मैच कर रहे हैं ना वो पर दिस वाले वाइन वाइन हो गए ये ग्रीन कलर की जैकेट है और पिंक कलर पिंक
वाइन पे बैठने तो तंग आती है वो जैसे कलर का सूट पाक लगी
कैलकाटा तक तो मतलब भाई की आवाजें जा रही है। विवान जनो
Yes, sir, done.
Okay. Now we are moving on a third point that is called electron affinity.
Yes.
What is electron affinity?
The affinity to accept an electron.
Yeah, tendency to gain electron. Okay.
Yes, sir.
So top to bottom, as a nucleus go inside, so electron affinity decreases, means tendency to gain electron. Any problem, मेरा बच्चा?
No, no, sir.
And left to right in a period, electron affinity increases due to increase in attraction on any problem, मेरा बच्चा?
No, sir.
So if we can combine these two effects, basically, what is ionization enthalpy and what is electron affinity? See, ionization enthalpy is the attraction of nucleus on the own electron, and electron affinity is the attraction of nucleus on the free electron. So basically, both are depending upon the attraction of nucleus. Clear?
Yes, sir.
So both are, size is increasing top to bottom. So IEA and EA will be decreases. And left to right in a period, size or radius is decreasing and these two are increasing. Note down this. Did you understand this summary or not?
Yes, sir. Okay, done.
Okay, can we move back to your book?
Yes, sir.
So periodic properties, read these three. Are you comfortable now?
Okay, I'll read them.
Okay, clear? So now arrangement, there are 7 periods and 18 groups, understand?
Yes, sir.
These periods are classified into different names. The first period contains 2 elements. Second and third contains 8. Fourth and fifth contains 32. Sixth 32 and then 19. Here. So
Yes, sir.
first one is known as very short. Okay.
Hmm.
These two are known as short period.
Hmm.
These are long. Just a minute.
मिलियन समजा जो पैसे तो कंपनीला तिथं तिथं जा
Long.
हा
This is longest.
तर कथा
This is incomplete. आपण केलं
खदो मध्ये गाडी
आपण
आणि की बेल्ट रखी तिथे ई बेल्ट
clear.
कपडे घ्यायचे तिथे घ्यायला मैं खाऊं मैं मैं
ये तरह हुआ इस तरह तू इतने आ जा चल
मला बोलते ते
देते छोड़ फिर इधर कलम जा खड़ा हो, इतने आ मैं कर
ले साफ कर दो
Done.
okay. So they have given periods. So how can you give the configuration? Did you understand this or not? For
Yes, sir.
lithium, there are 3 electrons. So you
Two,
fill
one,
two, 1, 2, 2, 2, 3. So always learn one thing more, that what are metals? Easily give electrons.
Hmm.
So as we move from top to bottom, ionization energy is decreasing. Clear?
Hmm.
So therefore metallic character will be increasing. Or we can say non-metallic character will be decreasing. Any problem, mera bachcha?
Yes, sorry. No, sir.
And left right in a period, ionization energy increases, tendency to lose electron decreases, hence metallic character decreases or non-metallic character increases. Any problem, mera bachcha?
No, sir.
Note down this.
Yeah, father coming to have दो दिनों तक कुछ पता नहीं चली
It is very kind of unclear because of the color. Please use black from now on.
Okay. Can I repeat it? If
Yes,
it is not readable.
sure.
Ionization energy increases. Clear?
Increases.
Tendency, yeah, tendency to lose electron decreases. Hence, metallic character decreases or non-metallic character. Any problem, mera bachcha?
No, sir.
So, as you see in the periodic table, we got stair-like structure.
Yes, sir.
So, at top there are metals are less, and at bottom metals are more. Clear?
Hmm.
Because metallic character is increasing from top to bottom.
Hmm.
Like this in the periodic table. You see this line from boron to astatine. Is it visible to you? Below it, all are metals. Above it, all are non-metals. And on this line, these are metalloids. Clear?
Yes, sir.
Comfortable, मेरा बच्चा?
Done.
घोल लगा जाएगा तो वहाँ बांधी बन जाएगा
So group 1 is also known as alkali metals. Group 1 elements. What are these elements? That is lithium, sodium, potassium, rubidium, cesium. These are also known as alkali metals. Tell me why.
Because they have one electron in their valence shell.
No, 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 no. When they dissolved in water, they form a strong alkaline solution. Due to OH minus, na? So the alkali metals are called so because when they dissolve in water, they make a solution strongly alkaline.
Yes, sir.
Similarly, have you noted down this all?
Yes, sir.
Similarly, group 2 elements, that is beryllium, magnesium, calcium, strontium, and barium. These are also known as alkaline earth metals. Why?
Beryllium, magnesium, then
Calcium,
calcium, strontium, and that is
barium.
yes, and B. Okay.
You know somewhat about the Hindi, then I can give you code in Hindi. Did you know?
Okay. Yes, sir. I
बेटा
do know.
मांगे बेटा मांगे कार सेंट्रो बाप रोए.
Okay.
BE for beta, मांगे for MG, car, calcium, centro, बाप रोए.
Hmm.
Did you understand this Hindi?
Yes, sir.
Oh, very good.
I understand Hindi. I can speak it as well, but I'm not very fluent. That's why I don't choose to.
Okay. So some codes I have made in Hindi now because these are the interesting stories. So I can give you that all. Why they are called alkaline earth metals?
Because they are found naturally.
Yeah. Basically, they also form the strong alkaline solution when dissolved in water, but they also present in excess in earth crust. Like calcium, you see the small kids can take eat soil because the calcium is present in that all. In earth crust, magnesium, calcium is present in an excess amount. So they are known as alkaline earth metals.
Yes, sir.
Clear?
Hmm.
So group 1 is alkali metal. Group 2 is alkaline earth metal. Then we can first move to the group 18. It is known as noble gases. Group 18 is known as noble gases. Earlier they are known as inert gases, but nowadays instead of word inert gases we use noble gases. Why?
Mm.
Earlier they are called inert gases, but nowadays we prefer a word noble over a inert. Why?
No, no, noble and inert because they have the electrons in the valence shell have completed the octet sorry, octet rule.
Mhm. No, no. My question is that nowadays we prefer a word noble over a inert. Instead of inert, we prefer noble word here
Mm.
because some of these are the inert gases, noble gases: helium, neon, argon, krypton, xenon, and radon. Nowadays, we find some compounds made by xenon, so they are not more to be inert. So nowadays, we use the word noble here. Clear?
Mm. Clear.
And group 17 elements, that is fluorine, chlorine, clear?
Yes, sir.
And then oxygen family, that is oxygen, sulfur, selenium, are known as chalcogens.
Chalcogens.
Yeah, means ore forming.
Okay.
मुंह में ना डालो. Clear?
Yes, sir.
And D block elements, that is group 13 to 18. Sorry, group 3 to 12. This is D block elements. Left side of it, the two groups are S block, and right side of it, six groups are P block,
Yes.
and at bottom it is F block. Clear? So we classify whole the periodic table into four blocks: S block, P block, D block, and F block.
Okay.
So basically, what are S block elements? These are alkali metals and alkaline earth metals. Two groups are there.
Yes,
These
sir.
are highly electropositive. Means they have tendency to lose electron. Okay. And these elements are highly electronegative. Clear?
Clear.
Both S and P block elements are collectively known as representative elements,
Yes, sir.
and D block elements are known as transition elements.
Yes, sir.
Why they are known as transition elements?
Because they're transitioning from metals to non-metals.
Yeah, because they are sandwiched between highly electropositive and highly electronegative. Not say metal and non-metal, you say highly electropositive and highly electronegative. Like Tejaswani.
Thank you.
How I can explain you? When there is some discussion between your father and mother, and they are just uh, betting on any point, you will be set in a center. Your papa asks you that Tejaswini, I am right, or mama asks you that I am right. So you get sandwiched between those one, and you
Um,
can stand up from there. Yeah,
um,
right.
okay. That would be a better situation. Yes.
Yeah. So there is a one side is highly electropositive and one side is highly electronegative. You're sandwiched between these two. Clear?
Yes, sir.
My kid is laughing on me because he is in the same situation. Okay, now the last one is F block elements. These are known as inner transition elements.
Yes, sir.
Why? Because these are actually present in between the transition elements. See, in the periodic table, the actual position of lanthanides is here. Above lanthanum, there are 14 lanthanides. Clear?
Yes, sir.
And above actinum, there are 14 actinoids. So write down this: S and P block elements are representative elements, D block are transition elements, and F block are inner transition elements. Understand or not?
Okay.
Check this out. Any doubt till here?
Yes, sir.
Check this all, beta. In next class, we can complete this whole chapter. Okay.
Yes, sir.
And do some questions. I think this is the easy one for you,
Yes,
or you are
sir.
getting difficulty to understand this chapter. Tejasvi, are you comfortable with these parts or not? Almost we
Yes,
have
sir.
completed.
Comfortable.
Okay, मेरा बच्चा, bye then.
Thank you, sir. Good night.
Good night, मेरा बेटा.